Hello, my name is Sam Bass. Today I'll be talking about Bode plots and specifically doing an example for control systems. To start off, what exactly are Bode plots? As you can see in the bottom, they are a graphical representation, specifically of how a system stability changes based upon what frequency is going at it. It is also referred to as a frequency domain behavior of a system. And when you look at the graph, the top one is the magnitude, that top portion, and the bottom part is the phase. Throughout the presentation, they won't be as on top like this as they should be, but I will still point out the key features of it. Looking at important aspects, there are two main important aspects. One is the phase margin and the other is the gain margin. Phase margin is where you look at where it equals 0 decibytes, and then on the top graph, and then you go down and look at where that point is and see how many degrees it takes to get to negative 180. And gain margin is sort of the opposite, where now you start at negative 180, and then you go to see how long it takes to get to 0 decibytes based on wherever it is. And why that's important is because those two spots are where instability could be happening. You want to have bigger gain and phase margins, and overall the goal is to have above 45 degrees. When looking at an example, we have this one, HS. It's a little bit more complicated than some others you might see. With this, it has a constant of 100. It has a real pull at S of -1. It also has a real pull at -10, and it also has a 0 at the origin. So based on this, we'll see how we can make the Bode plots. There's two different ways. We'll start off with the mathematical way. The first one is getting it into its standard form based on zeros and poles. So that's what we do in this first step. I did the math offhand just so it's not as time consuming. Secondly, you rewrite the constant, kind of just have a setting point for where your decibytes are going to take place. And then lastly, you combine them. Another way to do that is basing it off of the input and output and looking at all of the data that comes from it. With that, the equations listed over on the side to help create the Bode plots. Looking at an initial Bode plots, you can separate the components out, and that's what's happening here. The one on the left, if we looked at the beginning example, would be on the top, and the one on the right would be on the bottom, and it will follow suit like that throughout the presentation. So here's a rough one of what we see in terms of the Bode plots. And as you can see, the 20 is the constant. And if we take it another step, we can combine them all to make one single unified. In our context, it is that gray one. It might be a little bit harder to see, but it's this gray one right here that hopefully you can now see if we match it up. If I can just clear all drawings. Okay. So that is our unified overall Bode plot, which is even more clear shown here in the gray, but also you see a more of a black line. It's more curved. That is a more realistic version of what it would actually be like in real life if this were a true system and not just one I made up. And with this, it can be like more so analyzed via the equations we have on the left. And so again, I put it together and I'm just showing the graphical, but it can be simplified. And when we look at it closer, we can see that there are phase margins, and there's also a gain margin as well. Specifically, there's a couple points where the phase margin can take place. One can be seen here at 0.1, and another one over sort of in the 10 range. And so if we follow it down to look at the other graph, we go here, we're at around 90. We want to get to -180. So there's at least a giant range of at least 90 plus 180. So in that situation, we're pretty good. It will be pretty safe. When we look at the other range, here at 10, going from here, it is not as ideal as we'd want it in that sense of that phase margin, but it's not terrible because it technically is over 45, so it should be fine. If we look at the gain margin, starting here at the negative 180, at 100, we see it goes up over here. It goes up over here, and it has about a 40 decibite difference. So overall, it will be a stable system and a system you could work with. So hopefully you've learned some more about what a Bode diagram is, how it can be found, the various aspects that you can look at, but also how you can make it more accurate than just what its base version could be, but make it even more realistic by having those curved edges. And here, lastly, are my resources. Thank you for listening.